All right, we are continuing with Chapter 5 today. We are doing Section 5.2. So 5.1 was all about congruent triangles. I told you the triangles were congruent, and we talked about all the angles that are congruent, all the segments that are congruent. Today we're going to kind of do the same process, but a little bit backwards. So you're going to decide if the triangles are congruent and why. So first thing we're going to talk about, proving triangles are congruent. You can determine that two triangles are congruent without listing all the corresponding congruent sides and angles. There are 5 ways to do this. We're going to learn 2 today. We'll end up with 5 total by the end of the chapter. Okay? So yesterday we looked at 2 triangles and we talked about how all 6 parts matched. There were 6 corresponding congruent parts, and you can say they're congruent. Now we're going to learn the shortcut ways to say they're congruent. So the first one is called the side congruence postulate. We'll call it the SSS for short. If all 3 sides from one triangle are congruent to all 3 sides of a second triangle, the 2 triangles are congruent. So SSS, side. So here would be an example of when you could use this. Do you see? Yes, this goes in the box. Do you see how these 2 sides match? These 2 sides match. These 2 sides match. So if all 3 from one have a congruent corresponding match in the other, you can say, hey, these triangles are congruent because of the side congruence postulate.
So if they ask why, explain why it's congruent?
Yes. It'll say, are the triangles congruent? How do you know? Or what postulate would you use? So number 1 says, does the diagram give enough information to use SSS congruence postulate? Explain. So basically, do the 3 sides from one triangle all have a corresponding congruent side from the other triangle? What do you think? Yes. So our answer would be yes, and then just explain that. All 3 pairs of corresponding sides are congruent. I know I say make sure they have a match. That's not official enough to put in writing. So don't use the word match. That's kind of just like normal people talk. We want to sound a little fancy, okay? So say that yes, they all have a corresponding side that's congruent. Or yes, all 3 pairs of corresponding sides are congruent. On number 2, it says, does the diagram give enough information to use SSS, so side, congruence postulate?
No.
No, it don't.
Tell me, want someone defend themselves?
No.
Damon, you defend us.
Okay, so I think the people that are saying no are saying to themselves, well, these guys are corresponding congruent. These are corresponding congruent, but this one doesn't have anything labeled on it. Is that what you're thinking?
Yeah.
But the ones that don't have labels are what?
No.
They're the same line.
That's what I
Is that what you were going to...
I was gonna say they're correct because
Yeah, JK is the same segment in both triangles. So you can go ahead and mark this. Add this marking to your diagram because this segment is congruent to itself. And now we can conclude that yes, all of the sides are congruent. An included angle is an angle that's between 2 sides. So if I'm looking at these 2 sides, side AB and side AC, the included angle is the angle that's formed by those segments. Okay? So here the included angle would be angle A. Now, if you're kind of struggling with that idea, maybe it would be helpful to look at what the non-included angle is. So, if we're talking about these 2 sides, the included angle is the one that's in the middle of the 2 sides, the angle created by the segments. The other 2 angles are called the non-included angles. okay, because they're not between the two segments. So included, not included. And it matters which sides you're talking about. Like if we changed from, if we took AC off and did BC instead, then B would be the included angle. So it just depends which two sides you're talking about. This says name the angle included between the two sides. So if I'm looking at side WY and WX. So WY and WX. Which angle is between these two sides?
Z.
The answer's on the board, guys. It's angle W. So what I find helpful in this is to highlight what we're talking about, okay? So side WY. So WY is right here. WX is over here. What angle did I just make?
The right angle.
Angle W, right? Okay? All right, so let's look at the next one. So if I'm looking at XY, segment XY is right here. Segment YW is right here. What angle is that?
Y.
Angle Y. Very good. Okay, next one. Segment XZ, so this guy, and ZY is this guy.
Z.
Now, can I say angle Z?
Yeah. What is in the middle?
No.
Yes. Yes.
Does anyone else have any thoughts?
Yes.
Yes.
You have, because the Z could be two different angles, you have to specify which one it is by saying something like X, Z, Y.
Right, so there's another angle Z right here, right? So to keep them straight, we use the three letters. So I actually have to call it XZY.
What about X, Y, Z?
You could do, you could do YZX, but Z has to be in the middle because it's the vertex.
I really learned about triangles.
Because this is the chapter about triangles.
What we learned about squares later too?
We will learn about polygons, yes. All right, WX and XZ. So WXXZ.
X.
WXZ. You need all of them. You could do ZXW if you wanted.
How come you need all of them again?
Because there's another angle X. Like here's an angle X. So we could tell which one we're talking about. You have to use all three letters. All right, here is the next one. So we are now talking about the second way to prove that two triangles are congruent. This is called the side angle side congruence postulate. So if two sides, here's the kicker. It has to be the included angle. So the angle in between the two sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, the triangles are congruent. So here is an example. So if I'm looking at these two triangles, can you be quiet, please? Okay, so if you're looking at these two triangles, here's a side that corresponds with a side. Those are congruent. The angles included in the sides are congruent. And then these sides are congruent. So in each triangle, we have side, angle, side, corresponding with side, angle, side. So we call that the SAS postulate. So I always tell students when you're doing these to trace one triangle at a time. So start with what you know. I know a side, I know an angle, I know a side. Double check that it goes in the same order, side, angle, side. If you have the angle, then the two sides, that's way different. That doesn't work. So it has to go in the correct order. The angle has to be in the middle. All right, I want you to add a little side note. Write it.
No bad words.
There are no bad words in geometry class.
What that mean? Who said a bad word?
Write it down. I'm about to. Okay. If you're given the information out of order, let's say I'm given an angle, then the sides, then the sides. Do you see how this side is not, this angle is not between the two?
Yes.
If I'm tracing this triangle, I have A, then the S, then the S. What is AS? Okay, so that is a reminder that the angle has to be between the two sides. If you find yourself writing the ASS postulate, you are going to get it wrong. There are no bad words in geometry, okay?
So when we say
This does no. If this is the case, the triangles are not congruent. Okay? So if it's angle, then the side, you have to say no. Okay? The A has to be between the two S's.
You did the same stuff last year. When you was talking about associate.
All right, on number 7, it says, does the diagram give enough information to use side, angle, side, SAS, congruence postulate? So, what do I have in each triangle? Okay, so this is a side.
Congruent angles.
These are the congruent angles. What about these?
Parallel.
then the things that we put a line through it.
Yeah, you can put a line through it. It's the same segment in both triangles, so it's congruent to itself. So trace the triangles one at a time. I have side, angle, side, corresponding with side, angle, side. So can I use this postulate?
Yes, ma'am.
Yes, you can. And that's the exact reason why, because we have corresponding angles and the side in between the two angles. Other way around, the angle in between the two sides.
I love you.
All right, number 8 says, does the diagram give enough information to use SAS? So side, angle, side. So we have sides, right? And then this angle is right next to this side, but this one's way over here. You do know that these segments are congruent as well. So on the top triangle, you have side, angle, side, right? But on the bottom triangle, you have side, side, angle. So are they matching up? No. The order is not right. The angle that is congruent is not between the two sides. You have side, angle, side, and side, side, angle. There are no bad words. There are no bad words backwards either. Yes.
Is it supposed to be like a pyramid?
What?
Is it supposed to be like that?
The diagram looks like a pyramid? Yes, it's just a triangle. It's two triangles. Any questions?
No, ma'am.
Number 9, the directions say decide whether enough information is given to show that the triangles are congruent. If so, tell which congruence postulate, either side, 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 or side, angle, side, you would use. So, do we know either one of those here?
No. Maybe. Yeah.
What do you think?
It's
Yes. This is side, angle, side, matching with side, angle, side. So this is a yes by SAS. Very good.
I bet number 10 gonna be nice.
All right, number 10. Decide whether enough information is given to show that the triangles are congruent. If so, which congruence postulate, the two that we learned today, would you use?
SFF.
Yeah, if you notice, this segment is in both triangles. It's congruent to itself, so mark it as being congruent. And then you have all three sides matching with all three sides, so it would be yes by SSS. All right, number 11. Decide whether enough information is given. So same idea.
I don't care.
Yeah.
Yes. Yes.
No.
It's SSS. No, it's SASS. No, it's. Dang it.
I think it's sign English.
No, I think it's ASS.
Wait, if you turn
No.
No.
It's
SSS.
One is S.
Okay,
one is
so in order to be side, I would have to know some information about the third side. So SSS is automatically out, okay?
S.
So I'm actually going to go up there and trace it with, my iPad only gives me one pointer. Okay, so I'm going to point to something. What are these?
Tick mark.
Sides.
Angle. Angle.
Angles.
Do these angles match?
No.
No. So this is a no.
Neither.
Just none. We cannot prove that those triangles are congruent at the moment. Decide whether enough information is given to show that the triangles are congruent. So yes. All right. Same idea on number 12. You can add the information. You guys.
No.
You can add the information that those segments are congruent, right?
Yep.
Now do the same thing. Try to trace it. You can use 2 fingers.
Where do you start it though?
You can start on, so I could start here, right? Side, angle, then I would need these sides. Is that working out?
No, ma'am.
You can go the other way too, right? These sides, well this angle's right here. Do I have the angle next door?
No.
Do I have the angle next door this way?
No.
No. So it sort of falls apart right away either way. So this one is also a no.
Nothing.
You call it no, as indicated on the board with the letters N and O. If you want, sure. All right, number 13. Okay. Now, we're switching gears a little bit. This says, what additional congruence is needed if I want to use this one? So if I want to use side, angle, side, what do I need? Yes.
That's what I said.
So you need the angle L, and that would need to go with which one? Angle H. So the information that is missing is that angle L is congruent to angle H. If you knew that angle L was congruent to angle H, you could use the side angle side congruence postulate.
I'm not even gonna lie. Homework is gonna be so bonkers tonight.
All right, number 14. You should have enough time to get it done in class, so hopefully that helps. Number 14. What additional congruence postulate is needed if I want to use, this time I want to use SSS.
RTZX.
So RT would need to be congruent to,
ZX. XZ.
right. So careful with the order here. Remember, order matters when you're talking about the segments that are congruent. So see how R is next to the segment that has the 2 tick marks? And then I went to the T, which was next to 3. So you got to start at the one that was next to the 2 and go to the 3. You have to be in the same order. All right, couple more examples. Same idea. So now I want to use side, angle, side. So side, go to the angles. Which sides do I need? Good. So a few of you said it the other way, which would have been fine. If you started with U and then went to W, you would just have to start at X and then go to Z. That would be an appropriate answer as well. Either way would work. You can't flip-flop them, though. You can't say WU goes with XZ. You can't do that. Right.
Okay.
So I want to use the SSS. So I have these sides.
Yes.
Now, do not say ZX because although it's not labeled, it is something we already know. So that one's already there. You can label it or you cannot label it, but it doesn't answer this question. The side we still need
It's DX.
is DX to correspond with what? YZ. Good. Perfect. All right, I'm going to give you your homework, and we are going to work on it quietly because no one wants to do math homework over the weekend. Then we're going to continue with the chapter on Monday. You have a quiz on Wednesday of next week.